Yes, good morning, all of you. Yesterday, we started a little introduction based on the universe, how the matter exists in various forms, and we covered up to like different types of semiconductors. And from that, actually, we will continue when semiconductor chapter is going to start. So now I am going to change the topic like basic mathematics. I am going to introduce in this particular class. So be ready with the basic mathematics, such a easiest way I will try to explain to you. Let's observe here. When do you use differentiation? And when do you use integration? So when do you use differentiation and when do you use integration is the most important topic actually in the entire first year and second year physics. So for that purpose, first of all, I am taking a particle of mass m, and after applying some velocity to that particle, that means if you apply some force on the particle, then the body will move from position A to position B. Hence, we are saying one direction here, this we can find displacement. And later we can find even velocity, with what velocity the particle traveling, with what acceleration the body is traveling. So if you know the displacement, you can find the velocity and acceleration by using differentiation. That is the when we have to use differentiation in our regular day-to-day life. Now, if we go to the integration, when do you use? For that purpose, first one, acceleration. Second one, velocity. And third one, displacement. So now I have taken a reverse order. I think you observed. I have taken a reverse order. That reverse order is acceleration, velocity, and displacement. Now, if you know the acceleration, you can able to calculate easily the velocity as well as displacement. In this case, we are trying to utilize integration. This is the main important point as a 11th grade students. This is going to applicable any chapter, any kind of concept. Now, so displacement, you are finding velocity and acceleration, and you are using which? Differentiation. If you know the acceleration, then you have to calculate velocity and displacement, or even only velocity or only displacement. You have to use straight away the integration concept. Now, what is the differentiation and what is the integration? You need basically few points. That's what it is, a basic mathematics. Correct? So, in this differentiation, I am trying to give you one small formula, d by dx of x power n is equal to n into x power n minus 1, and integral x power n dx is equal to x power n plus 1 by n plus 1. These two formulas you should know 100%. Without knowing these two formulas, difficult to involve with the differentiation and the integration. That is simply differentiation like your mother, automatically the integration you are like father. So you have to feel in such a way, and you remember the names of your mother as well as father without forgetting. I think so you won't forget your mother and father name. In such a way, you should not forget your integration formula and differentiation formula. So whereas in differentiation, you are getting one simple formula, that is d by dx of x power n is equal to n into x power n minus 1. And integral x power n dx is equal to x power n plus 1 by n plus 1. So I told once again because this is more important to you. Now let's apply how to use this. See, d by dx of x power 1. Here what do you say, n value? 1. If n is 1, then here n is 1, x is x only, n is 1 and minus 1. This is x power 0, that equal to 1. Indirectly, dx by dx, numerator, denominator, same parameter that we are dividing means you will get 1 simply. So don't want to even use this formula. If you use formula also, you got the same answer like 1. Then, if you go for the d by dx of x square, that equal to, now what is the n value? 2. Now, 2 into, I am using in this formula that 2 value, x power 2 minus 1, that equal to 2x power 1 is nothing but a 2x. So derivation of x square is equal to 2x. Now, one more example, like a d by dx of x cube is equal to, now I think so you can tell me easily. What is the n value here? 3. 3 into x power n by n minus 1, that is 3 minus 1, that equal to 3x square. Now don't want further examples, even simply I will discuss with you, that is d by dx of x power 4. It is easy to give you the answer. 4 into x power 4 minus 1 is equal to 4x cube. Correct? Now d by dx of x power 5 is 5x power 4. 5 into x power 4. So now this differentiation formula is nowhere useful to you. Directly you can give the answers. So don't want to by heart even that formula after learning few things which are different examples. Now you can able to give me answer even d by dx of x power 10. Now I am giving this answer to you, 10 into x power 9. That is the simplest way to remember the differentiation. Just now I given all the explanation regarding the differentiation itself, but I didn't apply this to find displacement, velocity and acceleration. So now I will try to explain how this is going to involve with the velocity and acceleration. Now before going to that, you can continue further like how the integration formula I given. Now I am going to use small examples in this way so that I will come to the next level of physics. Now here integral x power 1 dx is equal to, what is the n value here? 1. So x power n plus 1, n is 1. 1 plus 1 by 1 plus 1, that equal to x square by 2. So if you use integral x power 2 means x square dx is equal to x power 2 plus 1 by 2 plus 1, that is x cube by 3. Similarly, integral x power 3 dx equal to x power 4 by 4 and so on. It is easy to remember. So basically you need these two formulas and then you can replace with the different examples so that you can understand how you have to analyze integration differentiation. Now I am going to explain you regarding differentiation, practically how to solve the problem, and integration, practically how to solve the problem. Yes. So please note down this, or you can take a screenshot so that I'll give you the further explanation based on this. Yes. Now let's see the differentiation, how you will apply in various examples. So now I am coming to the real application. The first application here, I am taking one example here. If a particle of mass m, if a particle of mass m and is moving with velocity v, and even it have acceleration when the particle have known displacement like x equal to a t square plus bt plus c. This is the in terms of meters I have taken as an example. Now, after knowing this displacement, I have to calculate this velocity v as well as acceleration a. So, now you try to apply this one velocity. So, from 6th and 7th standard onwards, you are well perfect this velocity term itself. Correct? So this particular velocity is nothing but the rate of change of displacement. The rate of change of displacement. That is in theoretically how we will explain. But that is nowhere useful for us while solving problem. But the rate of change of velocity, I am trying to write the rate of change of displacement, I am trying to write in the form of equation. That is d by dt of x. D by dt of x is nothing but a velocity. Simply what you can call dx by dt is nothing but a velocity. So dx by dt is nothing but a velocity. Now d by dt of x is the known value what we assumed earlier, that is a t square plus bt plus c. Now you have to take it parts wise. D by dt of at square plus d by dt of bt plus d by dt of c alone constant. Here a, b, c are constants. T is the time taken and x is the displacement. Now derivation of at square. A you can take outside because it is a constant with variable t. So d by dt of t square plus b into d by dt of t plus derivation of constant is always 0 other than the differentiation main formula. You have to remember this particular formula. D by dt of constant alone is 0. D by dt of alone constant is 0. Now from here I am continuing. A into derivation of x square. I given earlier formula to you. 2 into x power 2 minus 1. Same thing. Here I am giving in terms of t. Derivation of t square. 2 into t power 1. That means 2 into t. How it is? N into x power n minus 1. Here n is 2. 2 into t power 2 minus 1. The meaning of that? 2 into t power 1. That is simply 2t. So, derivation of t square is 2t. That already you know in the basic explanation. Now, plus b into d by dt of t. If you apply formula, if you apply very basic mathematics like differential, like a ratio, dt by dt is nothing but a 1. So, you can write just 1. Already derivation of constant 0 term. So, this is 2at plus b. That is the velocity in terms of meters per second. So, once you know the displacement, you can find velocity with the help of differentiation. This is the where you are using differentiation basically. So now you have a v. Now you know very well what is acceleration. Even in 10th standard, 9th standard, 8th standard onwards, from 6th standard itself, you have a acceleration term which you know very well. Everyone who are studying from 6th to 10th. Now you are studying 11th standard means it is so easy to you. So acceleration is the rate of change of velocity. The rate of change of velocity is called acceleration. So just take the screenshot or you can copy and I'll continue further acceleration for the same concept. Okay, now so here so far what we know is the velocity, you know. Velocity is dx by dt meters per second, that equal to 2at plus b, what I solved so far. Now I am giving you the acceleration. How do you find? With the help of differentiation. Acceleration a equal to dv by dt, that is the rate of change of velocity is called acceleration. Now that equal to d by dt of v is equal to, already you calculated, so d by dt of 2at plus b. So now I am going to continue from here, that is d by dt of 2at one part and other part is d by dt of alone b. B is a constant, you know very well. Derivation of constant value how much now? 0. This is 0. Now is equal to 2a into d by dt of t, the first part. Second part is a very known thing to you, that is 0. That is equal to 2a into, what is the dt by dt value? It is just ratio. No need even differentiation formula. That's nothing but a 1 plus 0. That is 2a meters per second square. A equal to. So acceleration of a body we calculated and velocity of the body already calculated. So in this manner we can able to use differentiation in the real situation when you know the displacement. So in this topic what you understand is, when you know the displacement of a particle, if you want to find velocity and acceleration, what you have to use? Differentiation you have to use. That differentiation formula is what? D by dx of x power n is equal to n into x power n minus 1. So in this manner you have to complete that velocity and acceleration. So now you see, I will ask you one small question, all of you. You know what is the velocity so far? What is the velocity? 2at plus b. Now the question for you is, what is the velocity at time t equals 0? That we can call as a initial velocity of the particle. First point is, what is the initial velocity? V at time t is equal to 0 is question mark. So I think so it is easy to give the answer. So you have to replace t by 0. So what is the velocity now? V is equal to 2a into 0 plus b. V is equal to b meter per second. That is the velocity of the particle initially. Now, my next question is, try to observe here. I want the velocity at time t is equal to 2 seconds. When a particle traveled from one place to another place, at time t equal to 2 seconds, what is the velocity of the particle? I think it is easy to understand now. In place of t, what you have to replace? 2 meters per 2 seconds. That is 2a into t is 2 plus b. This is 4a plus b meters per second. Now the questions they will ask you in such manner. That is the third point. What is the velocity of the particle at time t equal 2 seconds minus velocity of the particle at time t equal to 0 seconds? So here the particle will travel more distance and here the particle will travel less distance. Correct? So here the answer is dead easy. V at time t equal 2 seconds, 4a plus b. V at time t equal 0 is alone b. So that minus b. This minus b, this plus b cancel. The answer is just 4a. Like this, we can able to solve any differentiation problem without any difficulty with various examples. Yeah. Yes. Today, so far we discussed up to differentiation level 1 questions. So, differentiation level 2, I will try to explain tomorrow, and along with the integration, we will continue. Thank you.